So like I was telling you, the assignment from yesterday had a little bit of everything on it. I would like to go over quite a few of the different scenarios because there's some little things that you got to pay attention to that I want to make sure we talk about as a class so that I don't have to kind of go around and tell you individually, kind of the same thing over and over and over again. We'll do it as a whole class just to hit everybody. Let's start with the warm-up though. First off, what is the limit as x is approaching -2 from the right? Yeah, we're coming from the right. That means we are approaching that y value. We're approaching 1. Okay? What is we are approaching from the left? Coming from the left, we're approaching a y value of 3, which means, what's the limit? Does not exist, because we're not approaching the same value from both sides. So the limit at -2 does not exist. Okay? Now, quick question for you. What if, listen up please, what if I switch this graph and instead, what if the graph came through and went like that and this part wasn't actually there? What if that was your graph? Would there be a limit at -2?
Yes.
Yes. Even though there's not a point, there is still a limit, remember, because it's what are we approaching? You'd be approaching the same value of 3 from both sides, even though there's not a specific value there. Okay? That's what a limit is. What are you approaching? Okay? All right. Let's go to the worksheet. So take a look at your worksheet from yesterday. Hang on. We'll get to that one. That's one of them. I got a whole bunch circled already. So, and then if I miss any, then you can ask. Let's start with, does anybody have any questions on 1 through 12? Anything you want to go over 1 through 12? Because otherwise, number 13 is the first one that I want to talk about that you haven't seen a lot like that yet. And I'm going to give you a heads up in advance. I would make sure that you're paying attention today, more so than other days, because there's a lot of little details, which is why I want to go over some of these today. And if you're missing the little details, I'm pretty sure you're going to miss them on the test then too. Okay? So I would suggest you're focused and paying attention to those little details today rather than messing around talking, because you're going to miss something. Any questions on 1 through 12? Okay, let's start with 13 then. So first thing I want to mention, general. Your test is going to be very similar to this type of worksheet. It's actually, the worksheet's longer than the test. Okay, I want to say only maybe 20 total questions on the test. So this worksheet is longer than the actual test itself. But first thing when you're finding a limit, the first thing you should look at is, am I finding a limit that goes to infinity or negative infinity? Or am I finding a limit that's going to a number? The reason why I say those are two totally different scenarios, that's why I say look at that first. If you're finding the limit at a number, then you're in the, well, let me try direct substitution, let me try factoring, you're trying those methods. If you're doing an infinity or negative infinity type of problem, then that's where we're kind of eliminating the parts that don't really matter, and then kind of substituting in infinity, if you will. Okay, so they're two totally different types of problems. That's why I say start there. So if you notice on number 13, we've got x is going to negative infinity. So we're going to start with, let's look at the numerator and eliminate the parts that don't really matter. Remember, the part that matters is the highest degree term in the numerator and then also in the denominator. So even though that square root is there, the -2 is pretty insignificant in the big scheme of things. Okay? If you've got infinity squared and then you subtract 2, then you're basically subtracting nothing. So that goes away. In the denominator, x is the highest term, so the +3. You ignore that. And you just focus on what's left. Now, first question that I have for you, this is why I picked number 13. Until this worksheet, you have not had a problem where you had to pay attention to this, which is why I didn't really mention it much, because I didn't want to confuse you and then you not have any problems to deal with it. If you were to take negative infinity and substitute that in, I don't care about like the number or any of that stuff. What sign, positive or negative, would you get for the numerator? Positive. when you take the square root of stuff, you'll always get a positive answer. Okay? Square root of any, because you have to have the square root of a positive number, which means you get a positive answer. Okay? So you will always have a positive answer in the numerator, okay, for anytime you have a square root. What if you plug negative infinity into the denominator? Then you'd get a negative value, right? Positive divided by negative is what? Which means you know right away your limit, your answer is going to be negative. Because you will always have a positive number in the numerator no matter what you plug in for x. And you will always have a negative as we go to negative infinity. Okay? So I know my answer is going to be negative. I'm going to put that down. Okay? Now we just do the algebra. Okay? Now we look at the problem and we say, all right, let's simplify this and actually kind of do the algebra here. So in the numerator, square root of 5x squared, because that's all multiplied together, we can actually take the square root of each part. So we can take the square root of 5. And then what's the square root of x squared? X. I can actually evaluate that and simplify that. So we get the square root of 5 times x. Denominator, there's nothing to simplify. There's just an x sitting there. And now we simplify all the way down as much as we can. In this case, the x's cancel out. There's nothing left to do. There's your answer right there. It is a negative square root of 5 is your limit for that one. Okay? Main part that I wanted you to see on this was where the negative was coming from. Because I think a lot of people would eventually get the square root of 5, but if you're missing the negative, the answer's still wrong. Okay? So I want you to pay attention to that point. That's what I would suggest when you do a positive or negative infinity, you do first. Figure out what the sign should be. Okay? Let's do one more of those just so that you're understanding this. Let's do 14. If we take a look at problem 14, again, let's eliminate the stuff that we don't need. I don't need the 2, and I don't need the 7 down here. Okay, we're just going to focus on the highest degree term of numerator and denominator. Now, let's come up with the sign. If you substituted negative infinity into the numerator, what sign would your answer be for the numerator? Because you'd have a negative infinity times the negative that's already there, you'd get a positive answer. What do we say when you're taking square roots? It's always positive, which means your answer to this is going to be a positive answer. Okay? You know you're going to have a positive answer right from the start. So I'm going to kind of just put a plus sign there just to remind me that this answer is positive. And now we do the same thing that we did before. We do the same exact idea as what we just did. Now you do the algebra with what's left. I'm going to ignore that negative because we already know that the final answer is positive. So I'm just going to ignore that that's not even there. So I'm going to leave that as y. Nothing we can do there. And now when we take the square root, just like the last problem, I can take the square root of the 6. And the square root of y squared is y. And now at this point, we simplify just like we did in the last one, except other way around. The y's cancel out, and you end up with 1 over the square root of 6. Okay? I'm not. If you left it like that, I'd give you credit for it on the test. If you do rationalize it, it would be square root of 6 over 6. Okay? But if you left it like that, I'd give you credit. Okay? Okay, so that's the first type of problem I wanted to make sure that we discussed today. Because of the sign. Okay? Because of the sign, I wanted to make sure that you're understanding that positive and negative infinities, you got to figure out what sign are you going to end up with. Okay, you have to look into that. Next one, let's take a look down at 16 through 18. Okay, because they all go together. Those three all go together. If you take a look at problem 16, now notice we're back to a number. We're finding the limit as x goes to 3. From the right, from the left, and then overall. Which means this is back to one of those direct substitution type problems, factoring, those types of problems. If you plug 3 in, we get 3 in the numerator, we get 0 in the denominator. We get a problem at 3 over 0. Which we can't do, okay? But that's not that indeterminate form. It's not 0 over 0. Which means we're not going to factoring, which means we're not going to the other methods. Which is why I wanted to talk about this problem. Okay? Anytime you end up with a number over 0, that means this is a vertical asymptote problem. You have a vertical asymptote at 3. And if you remember back to when we talked about vertical asymptotes, a graph cannot cross a vertical asymptote, which means as a graph is approaching the asymptote, where does it have to go? You've only got 2 options. It's either got to go up to positive infinity, or as it's approaching, it's got to go down to negative infinity. It can only be one of those 2 answers if you have a vertical asymptote. So how do we tell if it's positive versus negative? We take a number like on number 16. If we're approaching 3 from the right, take a number that's a little bit bigger than 3 and see what you get, positive or negative. So for example, let's say I take 3.1. I'd have a positive over, it's fine too, I'm just trying to take something that's a little closer. Okay? All you care about is positive or negative. So if I'd have a positive number here, I'd have a positive number there, which means overall you're going to get a positive answer, which means the limit must be going to positive infinity. Okay? So that is positive infinity. Okay? We said whenever it's a vertical asymptote, it has to either go to positive infinity or negative infinity, one of those 2. Okay? Hold that thought, it's coming. On 17, it's the same thing, you're just coming from the other side of the vertical asymptote. So let's say if we're approaching 3 from the left, let's say we pick 2.9. You'd have a positive answer over a negative answer. Guys in the back, can we focus, please? We've been talking nonstop since we started. You're kind of paying attention, but you end up with 2.9 over some negative number. All we care about is a positive divided by a negative. Means you have a negative answer, which means that part's going to negative infinity. Okay? So on one side it's going to positive, on the other side it's going down to negative infinity, which means what's the answer to number 18? Does not exist, because you're not going to the same spot on either side. So this one does not exist, because those are not the same. Okay? So when you're looking at a one-sided limit, it is possible you can have positive infinity or negative infinity, but when it comes to an overall limit at a number, it's either a value or it does not exist. It's one of those 2. Okay? Does that make some sense? Biggest part of this one is recognizing when you have a number divided by 0, it's a vertical asymptote problem. You just got to figure out, all right, is it positive or negative infinity? Okay? So that's another kind of strategy as you look through that. Let's keep going. Let's go to the next problem. Take a look at 24 and 25. These are kind of similar to what we just did. There's not a lot of math. There's not a lot that goes on with these. Okay? And we haven't really talked about absolute value problems with limits, but you'll see they're very quick. Same kind of concept that we just did with the whole vertical asymptote idea. If we're approaching 0 from the left, let's say we pick some number that's to the left of 0. Okay? If you're thinking about a number line, I'm going to pick negative 0.1. Okay? If I plug that in, I would get negative 0.1 on the top. What's the absolute value of negative 0.1? Positive 0.1. What's my answer for this? Negative 1. You got the same number on top and bottom. Answer's negative 1. There's your answer for the limit. Okay? So you're just picking a number to the left or to the right of the limit that you're doing. On the next one, what's the only difference on 25? It's going to turn out to be positive. Because now you're picking a positive, let's say 0.1. You get 0.1 over 0.1. That's 1. Same thing in the numerator and denominator. Okay? So absolute value problems, the same thing. Just pick something on either side and just plug it in and see what you get. Okay? Yeah?
So you're going to plug in 0?
You could plug in 0, but what are you going to get? You're going to get 0 over 0, which you can't have, so now you got to try to figure out, now what do I do? Okay? So in this case, that's why we picked something a little bit to the right, a little bit to the left, and see what we ended up with. Okay? And it doesn't matter, by the way, even if we, like, Olivia doesn't like the 0.1s, so let's say we pick negative 1. Wouldn't you just have negative 1 over 1, which is still negative 1? Here, let's say we picked positive 1. 1 over 1, still 1. Let's say we picked negative 5. You'd get negative 5 over 5, negative 1. So it really doesn't matter what you pick. I'm picking something that's fairly close just to kind of stay with the concept of a limit. Okay? But it doesn't really matter all that much. Okay? Make some sense, hopefully? Okay, let's go a little bit further. Let's take a look at 29 just for a second. This one is another quick one, as long as you're understanding what to do when. Okay, 29. So on 29, anytime, this is one of those piecewise functions. And then previously what we did was what? How'd you deal with the piecewise functions? You graphed them. You graphed them and then you kind of used the graph to help you out. Now, you could graph this, but you don't always need to. And that's why I'm kind of going over this, is how do you know if you're supposed to graph it or not? Well, look at the limit that we're finding. You're finding the limit as you're approaching 3 from the left, 3 from the right, and then overall. Well, that's where you're switching graphs. If you're approaching 3 from the left, aren't we just using the top equation? Which means I don't need a graph, just plug it in. If I'm approaching 3 from the right, isn't that just the bottom equation? Just plug it in. Okay, so I don't actually need to graph these. You're just, since you're switching from from 3 to the left, 3 to the right, you can just use the appropriate equation and still just do direct substitution. Okay? So if you take 3 and I plugged it into the first one, 3 minus 1, there's your first limit, it's 2. Approaching 3 from the right means you're on the second equation. Plug it in, 3 times 3 is 9, minus 7 gives you 2. There's your second limit, which means what's the answer to C? 2, because you approach the same thing from both sides. Okay? Yeah.
I don't understand what the x is less than or.
That's an arrow. That's supposed to be an arrow. That's saying x is approaching 3 from the left. Oh, this part? This part up here?
What is that used for then?
Okay, so here's the idea. Let me explain. Good question. So what this is saying is you're on this part of the graph anytime your value of x is less than or equal to 3. So that's, anything to the left of 3 on the graph, you're using that equation. Then at 3, you're switching to 3x minus 7, that equation.
Okay, but
Okay.
when our.
So hang on just a second. Let me show you a visual. It would be like this. Let me get rid of some of this stuff. It would be like 3 from the left, we're on this part, and then from the right, we all of a sudden switch to a different graph. It'd be like that, like what we had on the warm-up. Okay. How we doing, okay? Starting to see some of the, like I said, some of the details on this one that you got to pay attention to. All right. One last one. Go to the next page. Just wait. That's where we're headed. 34 is what we're going to do. So first part. On the back side, if you just take a look, I'm not going to do 31 or 32, but if you take a look, this is one of those, again, direct substitution because you're dealing with a number. You get 0 over 0. Therefore, this is one where you multiply by the conjugate and try to work from there, okay, like we did previously. So that's 31 and 32 are those conjugate type problems. The reason why I focus on that first, when you look at the bottom problems here, 33 through 34, notice we're now going to limits as we go to infinity, or negative infinity, one of those two, okay? But you're still going to approach this the same way. General rule is this. If you can multiply, if you have a square root problem and you can multiply by the conjugate, you should. Okay, so for example, if you take a look at 34, what you need to see this as is basically the same type of problem as up here in 32. Put it over 1. Think of this as this over 1. And now, let's multiply by the conjugate. This one we'll do together. We'll do the whole thing. Okay? So if you multiply by the conjugate, we have the square root of x squared plus 5x plus x. Same thing in the denominator. When we do that, when we multiply out the numerator, again, remember that's just the difference of squares, so all we care about is the first part and the last part. The middle terms will cancel. So square root times the square roots go away. you get x squared plus 5x. Negative x times a positive x gives you a negative x squared. There's your numerator when you multiply that out. And the denominator is just the conjugate, okay, because you're multiplying by 1. So we have the square root of x squared plus 5x plus x. All right, so it's not a whole lot nicer. Matter of fact, it looks worse than what we started with. But again, now it's going to start to kind of we're going to clean it up here a little bit. In the numerator, the x squareds cancel out. Okay. And therefore, we can simplify here a little bit. Numerator, we get 5x. The denominator now is where we kind of have to, this is what's different from all those other problems. The ones when you had a number, this is where the factors canceled. Well, we don't have any factors to cancel yet. It doesn't work. So this is where now we're actually going to find the limit as x goes to infinity. Okay, so now I'm going to focus on just the square root for now. Okay? And do that just like we did on the front side when we did problem 13, problem 14, same concept. If I find the limit of this, well, the 5x, I don't really care about that because we're going to infinity, so that's not the highest degree term. So I'm not going to worry about that part. What's the square root of x squared? X. Plus the x that's still there. We haven't done anything with that. What do we get in the denominator? So you get 5x over 2x. The x's cancel, and that's where the 5 halves is coming from. That's where the answer is coming from. You end up with 5x over 2x. X's cancel. 5 halves is the limit. Okay? That is, I would say, this is my opinion, that is the hardest type of problem you will see. Okay? Because it's a conjugate one, it's a little bit messy, you got a little bit of everything in that problem. Okay? But that ultimately is where that 5 halves is coming from. It still is mostly a conjugate problem.
That's how I use it. And then he's got
no, that one you can just do direct substitution. You can just plug the 5 in and get an answer, I'm pretty sure. Okay. Remember, if it's a number, if it's approaching a number, first thing you should try direct substitution. It's when you're going to infinity that's a little bit different. Okay, here's what I want you to do with the rest of the time. And actually, let me kind of open it up for a second. Those were the questions I wanted to make sure we went over. Are there any other questions that you want to go over as a class, or would you rather work individually now? Individually? Okay, let's do that. So, what I have for you. Job number 1 is, if you're still working on this, work on this. Okay? Number 2, I've got another worksheet, same kind of idea. It's another basic practice worksheet where a little bit of everything, because again, we want to make sure you're getting ready. And I think the hardest part of the test is going to knowing what to do when. Okay? So, let me hand that out, and you will have the rest of the time to work and ask questions and see what you have.